Hello everybody, it's SHAZIZZ here. This is kind of an update from the number one, the solve video. Anyway, in that first solve video I had mentioned that this was part of the circuit. Alright, well that's no longer the case because this got fried out whenever I turned the frequency up too high, and so it is not doing so well. It's mentally ill right now. It won't give the right numbers. And this voltmeter down here, which is right over there, it still sort of works, but it's not registering the proper voltage. But nonetheless, since it's registering something, I'm going to go ahead and use it in this video. But the key to this video is that I'm going to take you on a bumpy ride here. Alright. This diode right here, there's that. There it is. That diode right there is out of a microwave oven. It's off the capacitor. It's a high voltage diode. And I'm going to have to sit down and write out a doggone schematic of this whole entire mess. But in the meantime, this is the input power source, and this is the cheapo motor controller, and of course we got our coil system, same as the video before. We got our wireless circuit right over here. What a mess. Okay, there's our wireless circuit, and using the same MOSFET as before, same capacitor setup, same bridge rectifier. The difference now is that the circuit is using a high voltage diode. It's using this charger pack for one of those oh doggone it, jump starting boxes that you get to jump start your car with. And that charging pack runs the circuitry that came out of the same pack, which basically that runs in to charge the battery so that you can use it for your jump starting. And over here I've got a couple more nickel metal hydride batteries. This doggone camera seems to be skipping on me. Alright, and down here, somewhere in this mess is a blue LED, which you'll see blinking at some point in time, just right next to the voltmeter. And so what I'm going to do, oh yeah, plus I got this over here. Now this circuit right here is basically just set to draw a load. That's it. It requires about 9 volts to run completely, and when all 4 lights are on, then it's 9 volts. Let's see. Of course, this is a 12 volt circuit that came out of the boost jumper pack, or whatever you call them. Alright, so sorry about the bumpy ride, and I'm just going to turn this thing on. First, I am not going to have these batteries connected. I'm just going to turn it on till I get my lights going. Okay, there's my lights going. Do-do-do-do. Alrighty then. Now, you notice that when the AC starts to get up there, that light there will start to blink. And so what's happening is this power pack is building up power inside them capacitors, and it's sending little surges over to this circuit board right here, which in turn you'll start to notice this will start to flash. When this starts to flash, it sends charges up the capacitor over on this side, and you'll get a little bit of blinking going on there. So right now it's trying to run that circuit. Right, running off of the frequency range at which I'm doing it. It's trying to run that circuit. And so from that point, I have this battery right here running on the same circuit, which you can see it's now starting to blink. Doggone it, I bumped the wire again. Alright, hold on. There it goes. Alright, you see that starting to blink. It's not even connected to the battery yet. I hope you're seeing that. Looks like my screen's freezing. Alright, so let me dim the light just for a second so you can see all that's lit up. Dang. Oh, well, yeah. If you also look down there, off screen, should be a, you should see that pulse of that fluorescent bulb starter right there. Sorry about the doggone mess here. Let me see if I can bring this up on the table. And burn it. Alright. We're back up on the table again. As soon as I get everything in view here. Alright. Now, I'm going to turn this off just for a second so you can see what all's lighting up. Alright, so you got the fluorescent bulb starter, you got the neon bulb, you got the wireless energy transfer, you got the little 9-volt circuit over there, you got the little blinking LED circuit over here. And so now what I'm going to do is I'm going to hook these batteries up so that they can begin to charge. Alright, so this one right here goes to that one right there. Notice the voltage on there is ridiculously high, so it's obviously not charging like it's supposed to be, or measuring. Alright, so now what I got on here is a low voltage alarm going on. Let me turn the light off one more time. Alright, so right now what I got going on is a low voltage alarm. That's that on that circuit right there, because it's not pulling enough to actually run the complete circuit yet. But good news is I can turn that off by pushing this button, and you'll notice that green LED's on, so that's saying that the circuit is charging. And that let's see, where's it at? Okay. This wire right here running off of the DC side. Where in the heck did it go? There it is. This wire right here running off the DC side of the rectifier is the one charging this battery. So, what's going on is on the AC side, that one there is charging this side over here, and on the DC side of the rectifier, that's charging this one over here. That's the voltage that you're seeing down there, which is pretty well out of range, because that voltmeter's got mental issues because of the high frequency. I turned this up too high and pretty much you know, put too much voltage to it, and inside of these cheapo deals are a lot of diodes and capacitors, tiny ones. And that was with the pop that I heard going on whenever I was running it the first time, when I overcharged it. And you could actually, when you're in the room, you could see that there was a spark. You could actually see it through there. But either way, this thing's turned way down. This 9-volt battery is not fully charged. And I'm going to have to buy me some more voltmeters and clean this mess up so that you can see exactly what's going on. But you got a 9-volt battery that is pulsing a MOSFET that is pulsing not one but 2 coils. You got plasma here in the neon bulb. You got plasma down here in the fluorescent bulb starter. You got that the capacitor being charged up. Watch as I discharge the capacitor. Okay, I hope you saw that. And I don't need to discharge this one because that's actually being drained off into this battery, so it's not even going to arc. But nonetheless, from that point on, this diode right here replaces the voltmeter that I talked about in the first video being part of the circuit. That's all it took was a diode, a high voltage diode off of out of a microwave oven. And this circuit right here is for the boost pack thing, or the charge jumper machine that I took that's the power supply that would normally charge those up. This is the circuitry out of it. You can see that green LED's on, so the circuit is running. But when you go to test, you don't get the voltage that you should. So it's not running to its complete possibility. So I've got to do a few more things, and I'll be able to get that thing to have enough constant power to run this right here. And from that point, it's charging this battery, and this one here is being charged off of this side of the deal, and that is also connected into this right here. And you can see there's 2 and almost 3 lights going, so this is almost getting the full 9 volts. Let me turn it off, turn the light off once again. You can see everything is lit up. So essentially at this stage in the game, it's only adjustments. That's all it is at this stage in the game. It's adjustments. That MOSFET is running so fast that you got to turn it down using this right here, so that you've got enough time for that magnetic field to saturate the core and the coils and everything, and then collapse. So you don't want it going really fast unless you want really super high voltage. It's still going fast, but it needs to be going slower than what that MOSFET's actually capable of doing. And this MOSFET, even after all this running, is not hot. It's just like semi-warm to the touch. It's not hot. Now if you have a brand new 9-volt battery on there, you got to turn this thing way down. So it doesn't even require 9 volts to run this deal. I would estimate anywhere from 6 to 7 volts, maybe even down to 5 volts would do this whole entire deal, just like we're doing right now. So I went through batteries, and I've run these batteries down until I get them down to where the battery's really weak. And this thing right down here, I can't remember what the actual specs that I mentioned in there, but it'll run anywhere from like 3 up to 12 or something like that. But nonetheless, that's a weak battery. It's running that circuit, it's running that MOSFET, that's pulsing this coil, that is charging that capacitor, which is running this bridge rectifier, and also running this off of the same AC frequency, running this right here that is running this circuit, charging this battery, this battery, and that circuit right there, which is also charging this battery right here off of the other side of the bridge rectifier. So it's not that we don't have enough energy. It's that we're not using it to its maximum efficiency. And so where I keep butting heads with everybody, go over and listen to some of the things that Russ from RWG Research he's talking about. He's saying a lot of stuff in different terminology that I'm trying to point out to you about voltage and being able to get work done with the potential. Voltage is pressure. I can pressurize this capacitor like I explained in this, with this right here, this is from my physics toy video where you can take and store pressure, and as long as the pressure potential is higher than the container that you're trying to charge, or the battery that you're trying to charge, as long as the pressure is higher, you can do that. Just like airing up a car tire from an air compressor tank. If you study how an air compressor tank, when you very first turn on, even though it might say it has 32 pounds, you can't get it to air up your tire like that. And so you got to bring the pressure in the air tank up higher so that you can pressurize that tire and push it up, not only lift the tire but the weight of the car off the ground, in order to be able to utilize that potential pressure. Just like this right here, you can store energy in that tank. That's a tank right there. This is a storage. This is a storage right here, and you can pressurize these containers, and depending on the number of turns on there or the thickness of the wire, it's just like Russ was explaining with the wire, the gauge of the wire, the thickness of the wire. The thinner the pipe, the higher the pressure. And what we got going on right here is literally using high voltage and pressure to do all this work right here. So looks like my video is up to about 16 minutes, so I got to shut this. Anyway, I wanted to bring this to you. That's the replacement for the deal right there. I'm going to go out and get me some more voltmeters, clean this mess up, and try to get a diagram together for you so you can get a better understanding of what's going on. Peace and love, everybody. Take care.